Rational equations are what we're looking at here. A rational equation is just any equation with fractions where the variable appears in the fractions, usually the denominator, but anywhere in the fraction technically, like 1 over x plus 2 equals 3 over 5x. That's a rational equation. And to kind of set up how I want to solve these rational equations, we're going to solve a linear equation that we've seen somewhat before, but I want to do something to make this problem easier. Instead of working with the fractions, you'll notice the least common denominator of 2, 4, and 8 is 8. And so if I were to multiply each term by that 8, we'd be able to do some nice reducing. 8 over 2 would reduce to 4. 8 over 4 would reduce to 2. And 8 over 8 reduces to 1. So now my equation reads 4 times 1x, or 4x, minus 2 times 3, or 6, equals 5 times 1, or 5. This equation with no fractions is much easier to solve. We just add 6, 4x equals 11, and divide by 4 to get our answer that x equals 11/4. That's much easier than dealing with the fractions. And the way we avoided the fractions is we cleared them out by multiplying by the least common denominator. And we'll do the same thing with the rational functions. We're just going to make sure that we check that our solution does not make the denominator 0. Remember, we cannot divide by 0. The denominator can't be 0. Very, very important. Don't forget to check. The denominator cannot be 0. It won't happen often, but when it does, we need to account for it. So here we've got x plus 4 over x minus 5/4 equals 2 over x. You notice my denominators have x's and 4's. So 4x is my least common denominator, so I'm going to multiply each term by that 4x. And when I do, I get some nice reducing. The x divides out, and I get 4 times x plus 4. The 4's divide out. I get 5 times x. And the x's divide out. So 4 times x plus 4, if I distribute, that's 4x plus 16. Minus 5x equals 2 times 4, which is 8. And now I have an equation with no fractions that I can solve. First, we'll clean up a bit. 4x minus 5x, combining like terms, is negative x plus 16 equals 8. Subtract 16 from both sides, and negative x equals negative 8. Divide both sides by negative 1, and x equals positive 8. Now, if I take a look back at my original denominators, if x was 8, so instead of x we had an 8, would that make any of my denominators 0? Nope, my denominators are 8 and 4. That works. So x, my variable, must be 8. Let's try this one. 1 over t plus 9 plus 2 equals 5 over t plus 9. So really the only denominator we have here is t plus 9. So that must be our least common denominator. So we're going to multiply every term by t plus 9. And what's important here is that also includes the 2. Every term gets multiplied by the t plus 9, which means it'll reduce on the fractions and be left behind on the number. So we've got 1 plus, let's distribute that 2 through while we have the chance, 2t plus 2 times 9 is 18 equals 5. And that will give us an equation that we're able to solve. First, combine like terms. So we have 2t plus 1 plus 18 is 19 equals 5. Subtract 19 off of both sides, and 2t equals negative 14. Divide both sides by 2, and t equals negative 7. We just need to make sure if t equals -7, and we plug that in, -7 plus 9, that's not 0. -7 plus 9, that's not 0. None of my denominators are 0, so this must be the correct solution. Let's try a few more examples. Here we've got 5 over t minus 7 equals -6 over 8t plus 5. We've got two different denominators, so both of those are going to be included in my least common denominator. T minus 7 times 8t plus 5. We're going to multiply each term on both sides by t minus 7 times 8t plus 5. That way, when reduced, the t minus 7 goes away on the left. The 8t plus 5 goes away on the right. And all we have to do now is distribute the 5 through. 5 times 8 is 40t, plus 5 times 5 is 25, equals. And whenever I see a negative, quite often I will add the opposite to make sure I don't lose that negative as I work. That is a -6. So we distribute -6 through. That's -6t plus 42. Very important we don't lose that. And then we solve the equation. First, get the t's all on one side by adding 6t to both sides. So 46t plus 25 equals 42. Subtract the 25 off of both sides, and 46t equals 17. Yep. Divide both sides by 46. And t is equal to the fraction 17 over 46. That does not reduce. And again, we'll want to check our denominators. If I put 17 over 46 in, you can see that none of these denominators turn out to be 0. We don't really care what the answer is in the denominator. We just care that that's not going to be 0. And it's pretty obvious it's going to be some ugly fraction, but definitely not 0. So that's going to be our solution. This next example, x plus 15 over x equals 31 over x. We've got just x in the denominator, so x is our least common denominator. It gets multiplied by everything, including the standalone x on the left. Most of them are going to divide out. But we're left with x times x, or x squared, plus 15 equals 31. We make it equal to 0 by subtracting 31. Why do we have to make it equal to 0? Because we've got an x squared in there. We can't solve directly for an x squared. So when we have x squared, remember our strategy is to equal 0, factor, and set each factor equal to 0. So we have x squared minus 16 minus 31. Make sure I subtract right. Equals 0. That's a difference of squares we should recognize. That's x plus 4 times x minus 4. And then we set each factor equal to 0. X plus 4 equals 0. X minus 4 equals 0. Subtract 4. And x is equal to -4. Or we add 4, and x is equal to positive 4. Really quick before we say that's the right answer, we look if we plugged 4 in for the x's. Are any of the denominators 0? Nope, the denominators are 4. If we plug -4 in for the x's, are any of the denominators 0? Nope, the denominators are -4. So our solutions of -4 and 4 must be correct. Here's a good problem. X over x plus 1 minus 9 over x plus 2 equals -14x plus 17 over x squared plus x minus 2. One thing I notice is this last denominator, we can factor it. And that might be useful to us. If I factor that last denominator using some guess and check, it's going to be x plus 2 and x minus 1, which are the exact same factors we already have over here to the right. That's really nice because that means I don't have to repeat them. I only have to list each factor once. So we've got x minus 1 and x plus 2, and that's it. X minus 1, x plus 2. X minus 1, x plus 2, x minus 1, x plus 2. I also want to clean up a little something. Again, we've got that minus in here. I'm going to add the opposite to make sure I remember we're dealing with a negative 9. Otherwise, that negative tends to disappear or accidents happen with it and we get the problem wrong. So let's see what divides out. The x minus 1s divide out. The x plus 2s divide out. X plus 2 divides out. X minus 1 divides out. That leaves nothing in that denominator. That's nice. So when we distribute, we get x squared plus 2x. Negative 9 times x is negative 9x. Negative 9 times negative 1 is a positive 9. Equals negative 14x plus 17. Let's clean up the like terms. So we have x squared minus 7x plus 9 equals negative 14x plus 17. Since we have x squared, we need to be equal to 0. So we'll add 14x to both sides and subtract 17. Add 14x and subtract 17. That gives us 0 on the right. And x squared plus 7x minus 8. Now that it's equal to 0, all we have to do is factor. And that's going to be x plus 8 times x minus 1. Set each factor equal to 0. X plus 8 equals 0. X minus 1 equals 0. Subtract 8 from both sides, and x equals negative 8. On the other equation, add 1 to both sides, and x equals 1. Quite a problem. But before I get too excited about having the right answer, we have to look at the original denominators and see if these are going to make the denominator 0. If I plug negative 8 in, negative 8 minus 1, that's not 0. Negative 8 plus 2, that's not 0. A little more work here. Negative 8 squared. Negative 8 times negative 8 is 64 minus 8 minus 2. That's not 0. That's good. We like negative 8. Still have to check the 1, but look at this first denominator. When we put 1 in there, what's 1 minus 1? It's 0. 1 minus 1 is 0. We cannot have 0 in the denominator. That means 1 cannot be a solution. The only solution we actually have is that negative 8. So again, make sure you always check your answers with rational equations. Make sure the denominator is not 0. Other than that, we just clear the denominators by multiplying by that least common denominator and solve whatever equation we have left. Take a look at the homework assignment as you solve some rational equations. Ask your instructor if you have any questions, and good luck to you.